Alright, we're going to talk about the basics of rotational motion. So if we have an object that starts to rotate, and it rotates through a certain angle, we end up with a certain distance that would be traveled in the linear direction that would be called S, or arc length. And that arc length, that linear distance, would depend on the number of degrees at which it rotated through times the radius of the object. If we take the derivative of both sides with respect to time, just like if we have dx dt, it equals v. If we have ds dt and take the derivative on the other side of the theta dt, on the left side we get the linear velocity, or tangential velocity, and over here we get the angular velocity, which is omega. And if we do it one more time, where we have dv dt and then d omega dt times r, we'll get the tangential acceleration times the angular acceleration times r. Now, it's important to know that that's the tangential acceleration. For centripetal acceleration, we have to use that it's v squared over r, and that v is equal to the omega r. So if we plug in this into that, we can then get the centripetal acceleration in terms of the angular quantities, which would be omega squared r squared over r, where that r will cancel one of those, so that the centripetal, or sometimes called radial acceleration, will equal omega squared r. I thought that was supposed to be an eraser there. Guess I was wrong. Alright, there we go. Alright, so what these derivatives mean, just like every other derivative, it stands for the slope. So if we have a angular displacement as a function of time graph, the derivative or slope of this graph will give us the angular velocity as a function of time graph, which then would give us the angular acceleration as a function of time graph. Okay, and of course the areas underneath these would then give us the upward graph. Now, that's going right along with our linear values. So you can see everywhere where there is an omega, that's where is replacing the v. Okay, alpha is replacing a, and theta is the displacement. Now that's going to work for all of the equations that we have that explain the linear motion. So with forces, linear forces are just F, rotational forces are torques. We're going to get into what replaces the mass, which is that letter I, okay? And here we have the omega being replaced by the V in kinetic energy. And what we can see is everywhere where there's an M, it gets replaced with an I. So when we talk about the kinetic energy, we'll see where we get that letter I from. All right, same thing with power. FV is now T omega. All right, so let's take a look at the rotational kinetic energy here, and let's figure out where we get that I.